Hi, good evening, everyone. The class will begin shortly. Okay, if you can see this live stream, could you just indicate so in the chat, please? Hello? Is there anybody with us here tonight? Could you indicate so in the chat, please? Selena Marshall, good evening. Anyone else is here with me tonight? Okay, Levano, Amanda. All right, that's enough. I could start with that. All right. Um, well, welcome to another day where we will be solving um, paper 3 questions. Tonight we'll be doing the January 2019 paper 3 paper. And before I start the class, I just want to share with you a motivational thought and we will begin. Um, Tonight I just want to speak to you all about the importance of having confidence in what you're doing. It's very easy for you to study for a long time, prepare for this exam, and go to the exam and panic, especially when you're a weak student. Because when you see something presented to you in a way that you're not comfortable with, it's very easy to panic. But I want you to exercise confidence in your learning, confidence in your ability, and sit and reason the question rather than panic. If you meet something that is really difficult, skip it and move on to something that it is easy. Always try to tackle off the easy things first and build confidence. Not overconfidence, but at least build some confidence so when you meet the hard things, at least you know you have some marks inside. All right? So it helps to boost your morale and work harder to get some better marks, okay? All right. So after doing this paper this afternoon, I must say compared to the January compared to the May 2018, I found this paper to be easier. Um but I'm gonna work out the questions, and what I'm asking of you is to just give me feedback. I'm doing a um solution video tonight, and I'm gonna explain, break down all the parts of the questions, but give me a little feedback. Tell me what you don't understand, and I will gladly go it over. Okay, but to make it a decent enough video that you could find what you're looking for after. I know that I'm dealing with weaker students, and I want you to at least be able to easily find what you're looking for when you're looking back at this video. Work at it through your pace, your own pace, and do the questions, follow my explanations clearly. But tell me, seeing that you're here live, as I walk through it, tell me, sir, what you don't understand, and I will gladly explain it, okay? All right, so January 2019, paper 3, question 1, part A. The information below represents the minimum temperatures in degrees Celsius recorded in country A for the first 20 days in a particular month. Okay, so this here represents the temperatures over the 20 days. Part 1. Complete the frequency table below. using the information above for 2 marks. All right, so this is very easy marks. If you don't know much self, you could pick it off. All right, you may have remembered this from primary school. Okay, so notice that what you're missing here is for 23. So you're going to go through here and you're going to just cross off the 23. Now, generally what you're going to do, you're going to do this. Every time you cross a 23, you put a line there and so on. Okay, on the tally. All right, but I would just count it and just finish it here. But that's what you're supposed to do properly, okay? So 1, 23 here, 2, 3, 4, 5. So 1, 2, 3, 4, 5. Everybody clear with that? All right, now for 25, you're going to go through again, look for what you have here. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. 1, 2, 3. So that's 5 and 3 is 8. Okay, so 26 here. You're going through now. 1, 2. 1, 2. All right, and I'm going to write 2 here. So is that clear with everybody? Please indicate so to me in the chat. So in order to just complete this frequency table, what you're doing, you just look at the temperature or whatever the observation is and look through the data that they gathered here. This is just raw data. And now we are processing the data. All right. Well, we are collating the data in a way that we could process it and make some inferences out of it. Okay. So you just cross out every value of 23. We go through it. We got 5. We just wrote the number of. We use sticks basically under this tally here and just draw it every time 5. It's just an easy way to count it. Okay. So we got a frequency of 5. Same thing we did for 25. We got 8. Same thing we did for 26. We got 2. All right. Simple, easy, 2 marks. All right. Obviously, not everything is going to be simple, but remember, each mark here is a percent in the paper tree. So every time you know that you knock off a percent, you know that's closer to passing and getting through this exam. Part 2. Determine the median temperature for 2 marks. Now, you'll recall here that the median is the middle number, and there are 20 observations. So n here is 20. All right. So the position of the median is given by the formula n plus 1 all over 2. All right. And here n is 20 because there are 20 observations. So 20 plus 1 over 2. This is 21 over 2, which is 10.5. What this means here is that the median is between the 10th and the 11th term. All right, so we have to find here the average. We have to find here the average of the 10th and the 11th observation. So I'm going to go back here to the frequency table, and I could do one of the two things. I could just count here and look for the 10th and the 11th one, or I could actually draw a cumulative frequency column, which makes it very easy for you to see. So I'm going to opt for the cumulative frequency column. Okay, so the first frequency here is 1. 1 plus 1 is 2. 2 plus 5 is 7. 7 plus 3 is 10. 10 plus 8 is 18. 18 plus 2 is 20. Now you'll notice that the 10th observation here corresponds to 24 degrees. And the 11th observation will be one of these 8 values here that represents 25 degrees. So the 10th term is 24 degrees. The 11th term will be 25 degrees. And I'll just add up these and find the mean of it to get the median. Because when we have an even number of observations, we have to find the mean of the two middle numbers to get the median. So the median, and the symbol for the median is Q2, is equal to 24 plus 25 all over 2. All right, so Q2 here is equal to 24.5 degrees Celsius. Okay, Sharice, I'm going to go it through again, all right? Let's start from the top. All right, so they ask you here to determine the median temperature. Now, when they did the survey, okay, when they collected this data, you would see that there are 20 days. All right, is 20 an odd number or even number? It's an even number. So when you place all these numbers in ascending order, what you would notice here is that to find the middle number, it's not that straightforward like when you have an odd number of observations. So the middle number, the median, is found by finding the mean of the two middle numbers. Now to locate the middle numbers, there's a formula we use. All right, the position of the median is given by n plus 1 all over 2. So this is useful to learn. N here is 20, so 20 plus 1 is 21. 21 divided by 2 is 10.5. What this means is that this 0.5 indicates that the position of the median is between the 10th observation and the 11th observation. So I have to go to the table here. All right, and I just draw the cumulative frequency. Cumulative frequency just simply means that I add up the frequency, and I will end up with the total number of observations. So this first frequency is 1. 1 plus 1 is 2. 2 plus 5 is 7. 7 plus 3 is 10. 10 plus 8 is 18. 18 plus 2 is 20. So that's how we calculated the cumulative frequency. So notice here that the 10th term corresponds to 24 degrees, and the 11th term is part of these 8 terms here, 8 observations that have 25 degrees. So the 10th term has 24 degrees, the 11th term has 25 degrees. So all I did here was say 24 plus 25 divided by 2 is 24.5 degrees. Now there's an easier way to look at this as well. All right. Now, generally, especially when you have larger sets of data, you would use this method. But you could also use a simpler method where you just place all these 20 numbers in ascending order, and you just locate the two middle numbers, and you'll see that it's 24 and 25, and you just find the mean of it, and that will be the median. Okay? So there are several ways you could do this, all right? I just showed you how it's done when we have data like this. Okay, you got 23.5 for the second part. It's not 23.5. Okay, what I would recommend, Sharice, is that write out all these numbers in ascending order and look for the 10th and the 11th term. Just count it, look for the 10th and the 11th term, and find the average of it, and that will be the median. That's okay if you get it wrong now. All right, now is the time that we sit down and we work through things and try to get it All right, so don't feel bad. All right, so that's part 2. All right, part 3. Calculate the mean temperature for the 20-day period. So there are 2 ways you could do this. All right, to have a more advanced way and to have a simple way. Mean, you're talking about average. You could just add up these 20 values and divide it by 20, and bam, you get your your mean. Or I'll do the more advanced way. Mind you, you're getting the same answer. So what you're going to do is take the frequency and multiply them by the temperature. So the frequency here is 1. 1 multiplied by 21 will give 21. The frequency here is 1. 1 multiplied by 22 is 22. 5 multiplied by 23 here is 115. 3 multiplied by 24 is 72. 8 multiplied by 25 is 200. And 2 multiplied by 26 is equal to 52. Now, when I add up all this frequency by f, add up all this frequency by the observations x, all right, we write this as the summation of fx. When I add up all these values here, in this last column here, I'm going to get here 482, all right? So the mean here is equal to the summation of fx all on n. And I know here that the summation of fx is 482. So I will take that here and just put 482 all over n here is 20. And I'm getting a mean here. The symbol for mean is x bar. Mean here is 24.1 degrees Celsius. So I'll go it through again and I'll touch on the other way as well. To find the mean, you can just simply add up all these numbers here, doesn't matter the order, and just divide by 20. That is one way. Another way, you can take the frequency and multiply them by the observations, which are the temperatures, all right, and get the frequency by the temperature, which will be just essentially doing the same thing, but this is just a shorter way of multiplying it, and you add up all these values. So the summation of f by x. This is x here. This is f, the frequency. X here is the temperature. So the summation of fx, when you add up all these values here, you're getting 482. Again, if you just add up all these things here, you can get the same thing. Okay? And you just take the summation of fx and divide by 20, and bam, you get your mean. Any way you want to look at it, CXC is not going to discriminate. All right? You just do it. All right? Everybody clear with that? Just indicate to me in the chat. If there's something not clear, let me know, please. Okay, well, if I didn't get a response, 24.1 degrees. All right, Tyrell, well done. So let's go on to part B. All right, so part B. The diagrams below represent the cross sections of two circular pizzas, A and B. The pizzas are similar but vary in size. Pizza A has a diameter of 15 centimeters and pizza B has a diameter of 30 centimeters. Part 1. Determine by calculation if pizza B is twice the size of pizza A for 3 marks. Alright, so I'm going to take a nice little shortcut with this. Alright, and show you how to easily do this working in a very short space. So they want to know if pizza B is twice the size of pizza A. So I will divide the area of pizza B by the pizza area of pizza A. And if it will either show me if it's twice, more than twice, or less than twice, and I'll easily come up with my answer. So I'll write here area of pizza B divided by area of pizza A. And the area, you will notice that this is a circle. All right. Pizza A has a diameter of 15 centimeters, which means, all right, the radius is the diameter divided by 2, which is 15 divided by 2, which is equal to 7.5 centimeters. All right. And the same thing goes for pizza B. The radius will be the diameter divided by 2, and this will be 30 all over 2, which is 15 centimeters. Rose, I would go through again when I'm finished, okay? Don't worry. All right, so what I did here, I took the two diameters that they gave me and just find the radius. Okay? Now, I could find the area of a circle with the diameter, but I just don't want to complicate things. Keep it as simple as possible and do the working. So I just found the radii of both pizzas. Everybody clear with the radii? The first pizza A has a diameter of 15 centimeters. Pizza B has a diameter of 30 centimeters. The radius is the diameter divided by 2 because 2 radii make up a diameter. Okay? So I was able to ascertain the radius of pizza B. So I'll call this RB and I'll call this RA. Okay? No, Tyrell. I just want you to know how I come up with the radius. It's 3 marks. Now, the area of pizza B here, we know that area of a circle is pi r squared. So this is the radius. Seeing that this pizza B is radius b squared. And area of pizza A will be pi multiplied by the radius of pizza A squared. Now I want you to notice here carefully, pi don't discriminate. All I did was cancel off pi here one time. Is that clear? Is that clear, class? So the radius of pizza B is 15, so this is 15 squared, divided here by 7.5 squared. And when I work this out on my calculator here simply, I'm just getting 4. So they wanted you to determine by calculation if pizza B is twice the size of pizza A. So therefore, pizza B is not twice the size of pizza A. It is 4 times the size of pizza A. For 3 marks. Alright, so I'll go it through again. They want me to determine by calculation if pizza B is twice the size of pizza A. So I just write out, we start with words, we formulate our problem, I take the area of pizza B and divide it by the area of pizza A. Alright, I know here that area is pi r squared. Area of a circle is always pi r squared. But r here will be the radius of pizza B and r here will be the radius of pizza A. Okay? So notice that pi is common. So instead of doing the calculation with pi and still getting 4, just simplify and take it out of the problem. And that's what I did. So this is 15 squared divided by 7.5 squared, and I'm getting 4. Alright, so therefore pizza B is not twice the size of pizza A. Alright, I didn't write this A clearly. Alright, it is 4 times the size of pizza A. Okay? Everybody clear? Alright, I'm going to go on to part B now. Part B2. Pizza B is cut into 5 equal sizes and sold at $6.95 per slice, while pizza A is sold as a whole at $9.95. Determine with reason which of the two options, a slice of pizza B or pizza A, is the better buy for the customer. Alright, so the best way to work this out here is to find the cost per centimeter squared, all right, or cost per unit area, all right, and that way you could compare the costs. Even though they have different costs and they have different sizes, you'll be able to make an educated decision as to which is the best pizza to buy, irrespective of the slices and so on, okay, because you're comparing area. So I'll write here cost per cm squared of pizza A so I know that pizza A costs $9.95. So $9.95. And I'll divide this by the area of pizza A. So this is $9.95 divided. Now area is pi r squared. So this is pi multiplied. The radius of pizza A is 7.5 and this is squared. Okay, and when I work this out on my calculator, I want to express dollars to 3 decimal places. Okay, that helps to make a very clear comparison. So that's why I know we don't generally deal with point something of a cent, but this will help us to make an educated decision. So 0.056, so this is 5.6 cents. Okay, okay, so per cm squared is another, can be expressed as to the power of -2. Okay, that's what per means. The minus means per, that it was in the denominator. So when I divide this, what this means here is that pizza A costs 5.6 cents per cm squared. All right. So let's find now the cost of pizza B. Cost per cm squared of pizza B. So the same procedure, it's just that I'm going to find the entire pizza. So I'll say 5 multiplied by the slice here, which would be $6.95, and divided by the area of pizza B. Okay? So 5 multiplied by 6.95 will give me 34.75. And the area of pizza B will be pi r squared. So this is pi multiplied by the radius here of pizza B is 15 centimeters. So this is 15 squared. And working this out on my calculator, I'm getting here $0.049. Or this is per cm squared, or this is 4.9 cents per cm squared. Okay, so clearly it's easier to compare the cents rather than the dollars. You would see that pizza A costs 5.6 cents per cm squared, whereas pizza B costs 4.9 cents per cm squared. So therefore, you can see clearly, irrespective of the slice sizes and so on, clearly you have an objective way of identifying which is the cheaper pizza. Cheaper pizza is pizza B. You're paying $4 and 4.9 cents per cm squared for it. So therefore you could write here a slice of pizza B is the better buy since it has the lower cost per cm squared than pizza A. Okay, if any of you have any questions, please put it in the chat. I'm going to go through the question again in the meantime. If I don't see any questions, I'm going to move on after I'm finished. All right, so they said here that pizza B is cut into 5 equal slices and sold at $6.95 per slice, while pizza A, it is sold as a whole at $9.95. Determine with reason which of the two options, a slice of pizza B or pizza A, is the better buy for the customer for 2 marks. Okay? So the only objective way to really compare this is to find out the cost per centimeter squared because they have different sizes and different prices. So I took here the area, the cost of pizza A and divided by, yes, it is tricky, Tyrell. All right. Take the area of pizza A. All right. Divide the cost by the area of pizza A. And I found here that the cost per centimeter squared is 5.6 cents. Okay. 7.5 is the radius because remember area is pi r squared. Okay. Same procedure again we're doing for the second part. cost per cm squared of pizza B. But this time, remember, one slice costs $6.95. But I'm dividing here by the area of pizza B. So I have to divide the total cost of a pizza B. So 5 multiplied by 6.95. That's how I get the 5 here, because there are 5 equal slices. You could see that up here, right? 5 equal slices. So 5 multiplied by 6.5 is equal to 34.75. And the area of pizza B is pi multiplied by r squared. The radius of pizza B is 15 centimeters, so this is 15 squared. When I work this out on the calculator, I'm getting 4.9 cents per cm squared. Clearly, you could see that this is smaller. 4.9 is smaller than 5.6. So therefore, pizza B, I'm paying less money per centimeter squared than I'm paying for pizza A. So therefore, a slice of pizza B is the better buy since it has a lower cost per cm squared than pizza A. Tell me if you're clear with that, please. Okay. Well, I'm going to move on here now. We have finished with one question. So let's get on to number 2. All right. So number 2 states, part A, in a football tournament, points are awarded as follows: 3 points for a win, 1 point for a draw, and 0 points for a loss. Part 1, write a 3x1 matrix P to represent this information for 1 mark. Okay, so this part of the question tested your knowledge of matrices, but more in an applied form rather than just a simple matrix. But it was actually a simple question. You could have picked up an easy 5 marks. All right, so for here, P, they want you to write a 3x1 matrix. So it has 3. The order here is 3x1, indicating that there are 3 rows and 1 column. All right, so there will be 3 points here for a win, 1 point for a draw, 0 for a loss. That's it. 1 mark. Okay? Part 2. During the tournament, Team Alpha wins are recorded 5 wins, 1 draw, and 3 losses, while Team Beta recorded 3 wins, 4 draws, and 2 losses. Part 2. Write a 2x3 matrix R to represent this information for 1 mark. Now again, you're going to use the order of the matrix that they give you here to guide you. It has 2 rows and 3 columns. Notice here that wins, draws, and losses will form your columns. So you'll have a win column, you'll have a draw column, and you'll have a loss column. All right, and there are 2 teams. So the teams will go in the rows, and the win, draws, and loss will go in the column. So I'll just write that here. R. All right, and for Team Alpha had 5 wins, 1 draw, 3 losses. Team Beta had 3 wins, 4 draws, and 2 losses. 1 easy mark here again. Is that clear? Okay, let's go on part 3 now. Calculate the matrix product RP for 2 marks. So what I'm going to do, I'm just going to write out RP here. So the matrix here R, and this here is 5, 3, 1, 4, 3, 2. All right, so that's R, and P here is 3, 1, 0. Okay, now let's check and see if these matrices are conformable. This here is a 2x3 matrix. R is a 2 multiplied by 3 matrix, whereas the order of P here is a 3 by 1 matrix. So what we do, we encircle the inner values and see if they are the same number. Are these 3? Both of them are 3. So what this means is that these matrices are conformable, so we could multiply them, and the outer values will tell you what type of matrix is going to be formed. So the new matrix will be a 2 by 1 matrix. So new matrix is a 2 by 1 matrix of what I would just say the general form AB. This is a 2 by 1. Is that clear? 2 rows, 1 column. Now I usually just draw this one side because it helps me to guide my multiplication very easily, and I recommend that students use that. All right, use the order of the matrices to determine how the new matrix or the matrix product will look, and just use the location of the elements inside of this new matrix to determine how you're multiplying the matrix. Okay, because it's very easy that many students, they accustomed working 2 by 2 matrices, and then bam, they get something like this and they don't know what to do because they just been regurgitating what they've seen, but they don't understand how the orders work. Okay, and this is something really fundamental in matrices. So we know that we're forming a 2 by 1 matrix. So this element here, A, is located in the first row of the first column. So I'm going to multiply the first row by the first column. So RP is equal to, this is 5 multiplied by 3 plus 1 multiplied by 1 plus 3 multiplied by 0. All right, first row multiplied by first column. The location of B here is in the second row of the first column. So I'm going to multiply the second row by the first column. So this is going to be 3 multiplied by 3 plus 4 multiplied by 1 plus 2 multiplied by 0. Okay? And now it's just simple simplification. So RP is equal to 5 multiplied by 3 is 15. 1 multiplied by 1 is 1. 3 multiplied by 0 is 0. 3 multiplied by 3 is 9. 4 multiplied by 1 is 4. And 2 multiplied by 0 is 0. So, again, we simplify. RP is equal to 15 plus 1 is 16. 9 plus 4 is 13. Okay, so let's run it through again. All right, WizKid, I am glad you learned something new, okay? But that is how matrices should be taught. Make sure that the students understand how these orders work, okay? Sometimes they run down to go and do the simultaneous equations and the transformations, and they don't fundamentally understand the basics of the matrices. And that tends to pose a problem when you have questions like these, okay? Mind you, learn to do your simultaneous equation and transformations. All right? So let's go through it again. Okay, so we have the two matrices here. This here is a 2 by 3 matrix. It has 2 rows and 3 columns. Okay? This here, P here, is a 3 by 1 matrix because it has 3 rows and 1 column. Now, in order to check and see if the matrix would, you could multiply the matrix if there'll be a matrix product that will be existent. Okay? You need to encircle the inner values when you write the order. If these numbers are the same, then you know for sure that these matrices are conformable, so you can multiply them. So the inner values would tell you if the matrices can, if they are conformable, and the outer values will tell you the order of the new matrix product. So the new matrix will be a 2 by 1 matrix. So what I generally do is just go one side and I just draw a generalized 2 by 1 matrix and just put some letters here. All right, and use the location of the letters to determine how I'm multiplying. Okay, so A is located in the first row of the first column. So I'm going to multiply here the first row by the first column. Okay? So 5 multiplied by 3 plus 1 multiplied by 1 plus 3 multiplied by 0. That's how I come up with the first line. The second element here, B, is located in the second row of the first column. So I will multiply the second row by the first column. So this is 3 multiplied by 3, 4 multiplied by 1, 2 multiplied by 0. Now it's simple. Simply simplifying this. 5 multiplied by 3 is 15, 1 by 1 is 1, 3 multiplied by 0 is 0. So 3 multiplied by 3 is 9, 4 multiplied by 1 is 4, 2 multiplied by 0 is 0. 15 plus 1 is 16, 9 plus 4 is 13. All right? And we have our matrix product. We got 2 marks there easily. All right? Now, what does the matrix product represent? The matrix product represents the total points obtained by team alpha and team beta. All right, so I'm going to write out that and I'll prove it to you otherwise. All right, matrices is not the only way you could work this, but they wanted this done in matrix form. So the matrix product RP represents the total points obtained by team alpha and team beta, where team alpha team beta. Now notice here, this is the matrix product. RP is 16, 13. So this here is 16, 13. What this simply means here is that team alpha has 16 points and team beta has 13 points. Now let's verify this. All right, let's use some common sense and go back and check this thing. Okay, they told me here that you get a 3 points win, 2 points for a draw, 3 points for a loss. So let's apply that here. Team Alpha got 5 wins, so 5 by 3 is 15. And 1 draw, 1 by 1 is 1, so 15 plus 1 is 16. So you could see here clearly in the matrix product here, this is 16. And in the answer here, you see that Team Alpha has 16 points. In the same way here, Team Beta has 3 wins, so 3 by 3 is 9. 4 draws, 4 by 1 is 4. 9 plus 4 is 13. They have 2 losses, so there's no points there. So the 9 plus the 4 is the 13. And you could see clearly here, Team Beta has 13 points. So they just use matrices to do something that we could do simply in our head. Okay? But obviously, this same type of problem is taken and modeled and solve a lot of more complex problems. They just use a very, very simplified example. Okay? Tell me if you understand that, please, and you understand the application of matrices to solve this problem. Let me know something in the chat, please. Okay, thank you, Tyrell. All right, so I'm going to move on. Last question, last part of this question, but last sub-question. All right, great. Great to hear that, Rose and Wizkid as well. All right, B. The values recorded in the table below represent the velocity of an object over a period of time. Part 1. On the grid below, 2 points are plotted. Plot the remaining 2 points on the grid and draw a line of best fit through the points for 2 marks. Okay, great. So they give you a table here. Time will always be on the x-axis, velocity is on the y-axis. Time is the independent variable, velocity is the dependent variable. The dependent variable, the independent variable always goes on the x-axis, the dependent variable always goes on the y-axis, and you can see that clearly here. All right, time is on the x-axis, velocity is on the y-axis. So they plotted 2 points here. So we just have to plot two points out of the table. So from the table here, when the time is 5 seconds, the velocity is 20 seconds. So you could see here, when the time is 5 seconds, the velocity is 20 seconds. So they plotted that one already. So now, when the time here is 12 seconds, the velocity is 34 meters per second. So I need to plot that one. So I come down here and I locate 12. Now you would see that every 2 blocks, 2 small little blocks here, represents 1 second. So this is 11 seconds, this is 12 seconds. And you're going up here, you're going straight up to 34. On this side here, you would notice that every block here represents a meters per second. So this is, so this here is 34. Okay? I'll explain again the independent and dependent variable just now, okay? Okay, so that's 34 meters per second at time 12 seconds. Let's get the next. No, Tyrell, it can't be x on the x-axis 13. It has to be 12. You can see 12 here, not 13. Okay, maybe that's a typo on your part. All right, on the keyboard, 2 is next to 3, so it's probably a typo. All right, now notice here on the graph, they have another point plotted. This would correspond to 8 seconds. Okay? 18 seconds. This will correspond to 18 seconds. This point up here that they plotted. So what we need to do is to plot the last point here. The last point here occurs at when time is equal to 25 seconds, velocity is equal to 60 meters per second. So going down to 25 seconds, and I'm going straight up this line here. All right, straight up this line. So that's 60 meters per second. So 25 going, oh, no. 25. Okay, this is the correct value. All right. All right, so now they want us to draw a best fit line. Now, before I draw the best fit line, let me just go back to WizKid and explain the independent and dependent variable. The independent variable is always on the x-axis. All right. The independent variable is not influenced by the dependent variable. The dependent variable depends or is influenced on by the independent variable. So for example, what that means here is that the velocity will depend on the time. The time don't determine the velocity. The velocity will be determined by the time, what happens in time. Okay? Now this has a lot of applications, not just in physics, but in all the sciences. Okay? But there are applications in business as well. I don't think it's just science students who have to deal with this. All right, as a best fit line now, again, yes, science students meet it a lot here in secondary school. But when you do statistics, All right, you have to do statistics in university. Whether or not you're doing sciences, you would realize that hey, you need to do best fit plots. Okay, so don't think that the body of knowledge that you're doing in secondary school is really small. There's a lot of overlapping of knowledge depending on what you're studying. Okay, so don't think you'll escape it. Now, what you're gonna do here, you want to draw a straight line through as many points as possible, and get the points evenly distributed where possible. Okay, so instead of just showing you a diagram where I drew it, I chose tonight to really draw this for you to see. Okay, because some good graph work skills. Okay, I want you to notice very carefully here. I was able to draw through all these points here. Okay, through all these points. Let me just make sure I plot everything correct. This is 10 seconds. This is 12 seconds. And this is 34. Okay, and this here is 2560. Okay, so that's my best fit line. Okay, I was able to draw through all. Somehow when I did it the first time, it didn't seem so, but all right. So that's our best fit line there, and you got 2 marks for that. Just plotting the 2 points and drawing a best fit line. Now you are just drawing the line where the points are. Okay, you are not extending the line. To extend the line, it's called a technique called extrapolation. All right, extrapolation will be tested in the question, but I choose not to extrapolate at this part in the question because I'll draw in a different color to show you different things. Okay. All right, so that's your answer there with your best fit line. Let's go to the last part now. Part 2, given that the linear motion of the object can be expressed in the form v is equal to a t plus u, where a and u are constants, use your graph to determine the values of a and u for 3 marks. Now, for those of you who are in my live streams for section 2 when I was doing functions, relations, and graphs, you would remember that I told you all to learn a formula called v is equal to u plus at. All they did was put the at before the u. Okay, and they did that because they wanted it in the form y is equal to mx plus c. And I'll show you how we take this equation, how they gave us here, and put it, just write y is equal to mx plus c and determine exactly how we're going to find a and u. So I write here that v is equal to at plus u. All right, and you can see from the graph, this is a straight line graph. Okay, and this is in the form of y is equal to mx plus c. Okay, where m here is the gradient, so the gradient is equal to a, and c, which is the y-intercept, is equal to u. Okay, so let's find the y-intercept. To find the y-intercept, we will do extrapolation, and that's why I didn't I just draw the best fit line where the points were. So now we're going to extrapolate on the graph, and I'm going to deliberately use a different color. Let me try something here. Let's try green. So I'm going to start here at this point and just continue on and try to keep it as straight as possible. Now, because you'll be doing this with a ruler, yours may be more accurate than mine. Okay. So when I'm extrapolating here on the graph, I'm getting here a velocity of 10 meters per second. Okay? you will have to double check and make sure that with a ruler, when you draw with a ruler and you're getting a straight line, if you're getting 10 or 11, okay? Please, when you do this question, just verify, just understand that there is some level of subjectivity how I'm drawing without a ruler here, okay? All right, so if it's 10 or 11, but right now I'm just going to work with what I see and what I did here, so I'm using it as 10, okay? So when I extrapolate or I extend the graph, I'm getting here the y-intercept. So therefore, the y-intercept C is 10 meters per second. So let's write that in here. So by extrapolation, thank you, WizKid. So by extrapolation, C is equal to 10 meters per second. So therefore, U is equal to 10 meters per second. That's the y-intercept. Everybody clear with that? All right, simple extrapolation. The next thing now we want to find here is A. A is the gradient, and the gradient is easy to find. What you do here, you go to your graph and you just identify 2 points on this graph. Okay? I know an easy point. Now listen, when you're finding gradient, you could choose any 2 points. But choose something that is simple, easily identifiable, and better yet if it's a point they gave you and it's on your best fit line. So I'm choosing here 520. Remember, it's always x before y. Okay? So 520, and I'm going to choose here 2560, which is another point on our best fit line. 2560. Okay? So I'm going to write out that here. So we have 520 and we have 2560. So this here is x1, y1. This here is x2, y2. And you're using the formula for gradient. Y2 minus y1 all on x2 minus x1. All right? Now remember they told you here the gradient is the acceleration. All right? And acceleration is defined as the rate of change of velocity. Okay? So y2 minus y1, this here is 60 minus 20 all over 25 minus 5. So m here, 60 minus 20 is 40, divided by 25 minus 5 here is 20. So your gradient here is equal to 2 meters per second squared. This is acceleration now, eh? So that's why it's meters per second squared. So therefore, A, well, M is equal, A is equal to, let me write this lower. A is equal to 2 meters per second squared. Okay? So your gradient here, which is A, is 2 meters per second squared. And that's the end of your examination. Any questions? Let me know, please, in the comments. Let me know if you understand. Okay? What I did here, they gave me this equation here, which is actually the definition of acceleration that they rearrange. Is also the first equation of motion. All right? So they'll give you this equation here, and I wrote the equation in the form y is equal to mx plus c, where m is the gradient, which is acceleration, and c is the y-intercept. All right? So I go to the graph here, and by extrapolation, I'm taking my ruler and just draw a straight line. I'm extending this line in line with the best fit line, and wherever it hit the y-axis, that's my y-intercept. All right? I got the initial velocity u to be 10 meters per second. Okay, that's your y-intercept. The next thing here, we want to find the gradient. So we come to the graph here, and yes, you can choose any 2 points on the graph. My recommendation, choose 2 easily identifiable points. I can identify easily 520. Do not put 25. Remember, it's always x before y. Okay, don't make that mistake, okay? So I choose 520, and I choose here 2560. You can see the 25 down here, 60 up here. Okay, and it's always wise to choose points further apart. All right, so I just wrote out the points, assigned them x1, y1, x2, y2. All right, substitute them into the equation for gradient. Remember, you need to memorize this equation. CSEC don't give you it. All right, substitute in 60 minus 20 is 40, 25 minus 5 is 20, and 40 divided by 20 is 2. So this is 2 meters per second squared. Remember, the gradient of a velocity time graph is always acceleration. Okay? So, no, they didn't ask you to write the equation of the line. You didn't need to write v is equal to 2t plus 10 meter 10. Okay? They didn't need to. Hello, Naomi. All right, didn't need to. Okay? All they asked you to do was to identify A and U. So we found A to be 2 meters per second squared and U to be 10 meters per second squared. All right, Wizkid, to be honest with you, I have basically completed all what I planned to do so far in terms of teaching. If people decide to turn out to class, I could plan some work, and but it wouldn't be paper tray because we've done all the possible paper trays. So what I could do is look at some older questions, because remember we did the most recent questions, which are the ones I want you to make sure and focus on. But if you want additional practice, we can look at starting with matrices probably from Sunday, and then we could work back with some section 2 work, and if I have time and have work prepared properly, I don't mind teaching every night, well, obviously, except Friday night. And we can practice because you're coming closer to your exam. But it all depends on if people turn out to the class, because I obviously don't want to do all this hard work and turn up and not many of you participate in the class, okay? So please tell me if you would want that. If not, I'll devote my time to some other activities. Please indicate so in the chat. Okay, so you want me to do some constructions. Well, as I said, transformation matrices. Okay, I'll see what I could pick up in those years. But most likely I'll more focus on I'll focus on probably doing the January 2017, May 2016, January 2016, and May 2015. Those 4 questions. Usually 4 questions are enough for a 2-hour class. Trying to chuck more in, those children they zone out on me. Okay, well, if y'all want it Sunday night, I'll put up a video, put up a notice that I'll have some live streams from Sunday night, 7 p.m. as normal. And we just come and practice some questions. But remember, you have to revise your theory, revise your theory, revise your theory. Okay? Well, that's it for this evening. I hope you enjoyed what I did. For those of you who benefited from my live streams, I have a reflection video on YouTube. Please at least share your experience there. That way I will know what I can change. I'll understand better how these live streams help you. So just check out the video and put a comment in there now. I'd appreciate it, okay? Have a good evening, everybody, and all the best in your examinations, okay? Good night.